Hey everyone, today we're going to look at parallel circuits. All this while, when we talked about KVL, we saw that the resistors were connected end to end and we called them to be connected in series. So the same current that was coming from the supply was flowing through all of these resistances. Now, the voltage drop across those resistances were different. But in case of parallel circuits, the resistors are connected parallel to each other. So, say in this circuit, for example, resistor R1 is connected across the points AB. Across the same point AB, the resistor R2 is also connected. So we see that the voltage across AB, that is VAB, is nothing but 10 volts because it's across the same A and B terminals that the voltage source is connected. So this means that VAB is going to be 10 volts, which implies that the voltage across R1 is also 10 volts and the voltage across R2 is also going to be 10 volts. So in case of parallel circuits, the voltage across the parallel elements is the same. Then what is it that differs? Now, the current coming out from the source is say I. A part of it is going to enter R1, I'll call it as I1, and the rest of it is going to enter R2, I'll call it as I2, and it'll come back as I. So by applying KCL at node A, so at node A, when we apply KCL, I is entering node A, so it'll have a positive sign. I1 is leaving node A, I2 is also leaving node A. So both of them will have a negative sign, and that is going to be equal to 0. So this is my KCL equation at node A. So I can say that I is equal to I1 plus I2. This is my first equation. Now, if I look at VR1, that is the voltage across R1, by Ohm's law, we know that VR1 is going to be equal to I1, the current flowing through the resistor R1, into the value of the resistance R1. So I1 R1 is VR1. Similarly, VR2 is nothing but I2 R2. Now, I can say since VR1 and VR2 are both equal to 10 volts in this case, so I can say I1 R1 is equal to I2 R2. So now, what is I1? I1 is nothing but I2 into R2 by R1. So, if I can replace I1 in equation 1, what do I get? So, let's see. I is equal to I2 into R2 by R1 plus I2. Now, when I take I2 common, I get R2 plus R1 by R1. This is equal to I. I can now rewrite this entire equation, making I2 the subject of my equation. So this means I can use this equation to find out I2. So what would I2 be? I2 is going to be equal to I into R1 divided by R1 plus R2. So instead of substituting I1 in the first equation, if I had to substitute I2, so I would get I2 in terms of I1. So in that case, what would my equation be? So that would turn out to be, you can see that I1 is I into R2 by R1 plus R2. So now we have arrived at a very important uh, tool or very important concept called as the current division rule. So the current division rule basically says that if I want to find a current in one of the parallel branches, then the general formula that I need to apply is that the current through a particular branch, say X, is actually given by the total current which is entering the node where that all those branches are connected into the opposite resistance. What does opposite resistance mean? So suppose if I want to find the current through R1, then I need to put the opposite resistance, that is R2, at the numerator. If I want to find out R1, I need to put R2 at the numerator. So in this case, for the general one, instead of R2, I'll put it as opposite resistance divided by the sum of resistances. So this is the general formula for current division rule. So let's try to find out the value of I1 in this circuit. So we know that the total current IT over here is 5 amps. We know that R1 is 10 ohms and R2 is 20 ohms. So if that is the case, what is I1? I1 is simply going to be 5 into opposite resistance. Because I want to find I1, I have to put R2 at the numerator, which is 20 ohms, divided by the sum of the resistances, which is 30. So we can say that I1 is nothing but 10 by 3 amps. Then what about I2? So I2 is going to be nothing but, so there are two ways of finding it. See, the total current, because this is a simple circuit, the total current we know here is 5 amps. So 5 minus I1 will be I2. Or we can apply the current division rule again and say 5 into opposite resistance this time is 10 ohms, because we need to find out I2. So the opposite resistance to this is R1 divided by the sum of resistances. So this is nothing but 5 by 3 amps. So this is the concept of current division rule. I hope you've understood the concept clearly. So that's the general formula for current division rule. Another important aspect which we need to discuss at this point about parallel circuits is to find the equivalent resistance of a circuit where all the resistors are connected in parallel. So here, for example, if I want to simplify this circuit, then I can actually put this voltage source, I'll call it as Vs, and I want to replace the two resistors by a single resistance, say R equivalent, which is equivalent to R1 and R2. So what should the value of this R equivalent be? Such that when we redraw the circuit in this manner, in a simplified form, the properties of the circuit are retained. So to find out that, we can say that VR1 is equal to VR2, where VR1 is the drop across voltage R1, VR2 is the drop across R2, Vs is the source voltage. We know that Is is the source current here. It enters R1 as I1 and enters R2 as I2. So from Ohm's law, we can rewrite VR1 as I1 R1 and VR2 as I2 R2. We also know that I is equal to I1 plus I2. Now, if I can write I1 as VR1 by R1 and I2 as VR2 by R2. So this is equal to I. What really is VR1 and VR2? They are actually equal to Vs, because after all, they are the voltage drop across the same terminals AB. So I can replace them, VR1 and VR2, with Vs. So I'll get Vs by R1 plus Vs by R2 is equal to my I, or Is, according to this circuit. So I can write Is is equal to Vs 1 by R1 plus 1 by R2. So here we know that V is equal to IR from Ohm's law, which means that V by I is equal to R. So if I can rewrite this, right, if I get Vs by Is, I'm actually going to get the total resistance of the circuit, which is exactly what we are having over here. So the current of the circuit should not change. The voltage is going to remain 10 volts. And what is the value of resistance that I should connect such that is does not change, and it replicates the behavior of the circuit and replaces the two resistances. So what is that R equivalent? So in order to find that, we can say it is Vs by Is, which is ultimately what we are getting over here. Vs by Is is nothing but 1 by R1 plus 1 by R2's reciprocal, or 1 divided by this entire thing. So we can write R equivalent to be equal to R1 R2 divided by R1 plus R2. So this is the equivalent resistance for parallel circuits. Now if we had more number of resistors connected in parallel, so say R3, R4, R5 and so on up to some Rn, I can still find the equivalent resistance of this circuit applying the same formula. So the formula will just be extended. How would it look? So R equivalent will be given by 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn, the whole inverse. Suppose now I consider a scenario where I'm connecting a wire without any resistance in parallel with all of these resistors. Then what would the equivalent resistance be? So to say, the resistance of this wire that I've connected is actually 0. So now what would happen to this equivalent resistance? So by including that also in this formula, it would actually be 1 by 0. So 1 by 0 is nothing but infinity, and there is an inverse over here. So I'm actually going to get 1 by R1 plus so on up to 1 by Rn plus an infinity, the whole inverse. So that would be 1 by infinite, which is nothing but 0. So we see that if I connect a conductor across all of these resistors such that its resistance is 0, then the equivalent resistance of the entire circuit comes down to 0 ohms. So what would happen if there is a circuit like this? If the current I is going to come out from this voltage source, then all of this current is directly going to go into this branch with 0 ohms resistor and come out, which means that I1, I2, I3 and all of these currents in these branches is going to be 0. So in that case, if I'm going to connect a conductor whose resistance is 0 in parallel to this circuit, then I1 and I2 and all of these is going to be 0. Why is that? Because current always takes the path with least resistance. So in this case, the path with least resistance is the path that is offered by this conductor with 0 resistance. So the equivalent resistance of this circuit is going to be R equivalent is equal to 1 by 5 plus 1 by 5, the whole inverse, which is nothing but 25 divided by 10, which is 2.5 ohms. Hope you could pick up some useful trivias from this video. Thanks for watching, and please do subscribe to my channel.